It is with great pleasure that I would like to call on stage our next speaker, Professor Bruno Correia. Bruno has been with us as a professor in bioengineering since 2015, and his lab focuses on developing computational tools to develop new proteins, specifically aiming at immunoengineering. So, Bruno, the stage is yours.
Thanks a lot. Thanks a lot. Thanks a lot for everybody to come over today. It's a pleasure to see you here. So I'm going to tell you about how we've been tackling this problem of molecular design and protein engineering in our lab, particularly driven by AI and machine learning techniques. So for most of you that don't think about proteins all day long, they are very close to you, and you can imagine that besides being sort of this very beautiful or mesmerizing even molecular structures, they are involved in pretty much every role that happens in your body and in situations of disease as well. While in the beginning, most of the community has focused on understanding how these proteins in fact work in biological systems, what we have now evolved to do is in fact engineer proteins for other functions and other types of applications that we are interested for the benefit of societies. Now, what is the dream and what is underlying the potential of engineering this particularly class of molecules? So you can think about pretty much anything you would like to solve in the modern world, going from applications in medicine to technology to sustainability. And really now we're sort of like getting to the edge where these technologies are promising to the point of making us believe that we can actually achieve these goals. Now, clearly the potential for translation and innovation is huge, particularly in a country like Switzerland, where historically bioinnovation has been a driver of the economy. And in the sense, what I want to just give you an idea is really how the technologies are evolving, and giving you a picture. I'm sure that all of you are familiar with these techniques that we saw here so much in the news, which is about image generation. So if you want to think about molecules as images, we now have powerful approaches which allow us to learn from the data and essentially just generating all these molecules at will. Ultimately, you could think about why to do such a thing at EPFL, and really I don't think I'm giving you here any news that one of the hardest things to do today is actually to capture talent. And I can tell you that we have a lot of talent around here across every level, starting from our undergrads to our faculty, I would hope. But really that there's also this environment of interdisciplinarity, which is essentially part of an ecosystem where innovation plays a big role, and that's why you guys are here today, and that's why we're happy to talk to you. So giving you a couple of examples of how we've been applying these technologies, you could think about it at a very high level on thinking about learning patterns of molecules, just the way that you learn patterns in images, and how we use geometric and machine learning techniques in order to learn these patterns, so that then we can create new classes of molecules that could be things like viral inhibitors, smart therapeutics, and small molecule sensors. In a different type of example, and here showing you some of the people that actually do the work out there in the lab, where we have used these techniques also to the design of novel vaccines that we actually tested in vivo and realized that their potential was indeed there. Particularly now also thinking about how we can use these technologies to engineer more complex systems and the next wave of therapeutics. Here I introduce you this concept of CAR T cells, which are essentially engineered T cells from patients that then are injected inside of the body again to go and eliminate tumor cells. And here what we actually did was to create this system where we could actually control remotely, and you see there the depiction in the middle for the molecules that we generated in the computer, and that now we at will, just by taking an oral drug, we can actually control the activities of these T cells. So with this, I complete my presentation, and so thank you all for coming. It's a pleasure to have you here, and I hope to connect with you in the breaks. Thank you very much.